Simon.
Hello, Dave.
Great to see you.
How is life?
Terrific.
Everything good?
Yeah, great to be here with you, and great to be with our audience. I think we got over 130 people here with us today. So
very excited to transmit here live from Sønderborg in Denmark.
In our new demo room. So turned into studio. So
topic is frequency sharing, and I think we just don't lose time. We just immediately start with our presentation.
We'll jump right into it. Okay,
good. So it is about frequency sharing, as I just mentioned before, on our Tetra and DMR base station BS422. So
yeah, I'd ask if you've got any questions. We're going to try and condense a whole lot of information into the next 30 minutes here. So if you've got any information, if you'd like to see copies of the slides, I'd ask you to put your name and your email address into the chat. We'll collect all those, and then at a certain point later this week or early next week, we'll fire out the slides to you. So if you could do that now, and we'll probably remind you of that later. Thanks.
Okay, good. So the agenda for today is just first we talk about the kind of the key challenges, or what's the motivation behind of inventing a new functionality like this frequency sharing, and then we will discuss some use cases with you, and we will also ask your opinion about them, how to actually use it. So coming to the challenges, what if you have a narrowband PMR system, very often you run into a problem that you do not get the frequencies. It's very difficult to get frequencies. Actually.
Yeah, especially in urban areas. These are always issues. Doesn't matter what part of the world you're in. This is something that you're going to have to contend with at some point.
Exactly. And if you get frequencies, then they might be very expensive. So aim is, of course, to minimize your frequency use so that you only apply for the licenses that you actually need. So there is no meaning to have too many frequencies. And one way to reduce frequency needs is to use repeater systems. And but then when you have a repeater system, the problem is it will add complexity to your system.
So when you say repeater system, you're talking about off-air repeaters, optical repeaters. What maybe explain that a little bit more.
Actually, the concept applies to both
of them,
but the use case we are going to show here will be related to optical repeaters.
Okay, good.
So for tunnel coverage, yeah. But let's see how we address actually these challenges and how we can solve this problem. So we will come now to our use cases. So we will have three cases. One is the one I just mentioned before. So if you have a tunnel coverage and you're using external repeater system, when you use the DAMM BS422, you can actually do the whole thing without external repeaters.
The BS422, maybe Simon, I should just introduce, this isn't a growth over here. This is our BS422 just mounted on a mast here in our demo room, just so that they're aware of that.
Yeah, right. And I think when we are on full screen again later on, so
we can show them as well.
We can show it. So they are really tiny base station, not bigger than a repeater. Then we will also look at a use case when you have a kind of a long line to cover with a low density, so for a railway, or if you have a pipeline to cover, for example, or a motorway. So there the frequency
would come in handy.
Sharing could be quite handy. Yeah, and then also the last case to do geo-redundancy in base stations could be quite important use case.
So basically what you're talking about there is you double up your coverage just in case one site fails, and then
in a sense, yes. So we will see it in detail. So the point there really is in many places when you just build one base station which is sufficient from coverage point of view, you just want to be sure that if the whole site, for example, fails, or an antenna system, that you still have coverage. So that's what is geo-redundancy about. Good. All right, let's now have a look how tunnel coverage is typically done. So the way how you usually build it when you have a conventional Tetra system, so here we talk about Tetra, but it's also for same rules or the same functionality is also available for DMR or even analog systems. So what you need is a base station, and on the base station, then you feed the RF signal to a master unit, and you will have an optical fiber along the tunnel. So that's why you call it also optical repeater system.
So you basically sniff RF energy off, put it into a head-end master unit, turn it into light, and
exactly,
run it down the tunnel.
And then in the slave units, in the repeater units, there you actually transmit the RF itself, and in the uplink direction it's just vice versa. So you pick up the signal.
How do you manage those repeater slave units? Is that part of your Tetra system, or is that?
This is actually exactly one point with what we would like to address. So the problem here is actually the managing of this system, because if you have this system which works actually quite fine, you end up like with two different systems. You have the Tetra network, but on the other hand, you have the repeater network. So you need to operate both. You have two configuration systems. They are in a way like completely independent from each other. So it really makes the whole network rather complex. So from operation point of view, and also when you think of maintenance, so sparing, you have lots of spares. So you have the base stations, you have the master unit, all the repeaters. You have lots of different hardwares you need to take into account.
And does what happens when you're laying something like that out? I suspect you're going to introduce attenuation and noise. Is it how do you balance a system like that?
Simon? Of course. Also, we can then compare just to our proposed solutions. Also, whenever you have multiple elements in the RF path, you will always add noise. So potentially the receiver sensitivity of such a receiver unit is never as good as the one of the base station itself.
Okay.
So and I think also one point here is the redundancy. So if you would like to build up redundancy with such a system, it's getting rather complex, because, for example, if the base station fails, then the whole coverage, everything is gone.
Right.
So or also if the master unit fails, so basically you need to duplicate everything.
Double up on everything, right? Okay.
Yeah. No, now we discussed a lot about how it is usually done, and I think, dear audience, surely you're interested how we are now doing it at DAMM. So if you put a BS422 base station here, you can configure them as master-slave units using this frequency sharing.
Okay.
So they are actually fully synchronized with each other, and the RF is transmitted at exactly the same time from the master and also from the slave unit. So in this sense, it does more or less the same as the repeater system. Actually, it does it a little bit better because it's fully synchronized. There is really no delay behind. And then you cover basically exactly the same areas with the repeater system. But the point that you mentioned before is the receiver sensitivity, for example, of this base station is much better, because from hardware point of view, it is exactly the same unit. So you have the same hardware units, it's just different configuration and different licensing from our side.
And you've eliminated that optical fiber that transports that. But you're running on the IP backbone, the same IP backbone that could be an optical fiber. We could
exactly. I nearly forgot to tell this. So you actually get rid of this optical fiber. So you do the whole synchronization is done through the IP backbone with a precision time protocol. You synchronize the base stations. And so you do the timing in a way that they are really running fully synchronized.
And then if you lose the master, and then what happens at that point? Because if there's a redundant piece here, how do we deal with redundancy?
So there is actually a major difference compared to the optical repeater system. If this master here fails, then any of the slave units will automatically take over the master. So you have full redundancies. If here the master fails, then you still have full coverage in the areas of the other three base stations. So the resiliency is much higher compared to this optical repeater system. And then, as I mentioned before, so you have only one piece of hardware. So from spare part point of view, it is very simple. You can build up your whole network for tunnel coverage, and that's actually also outdoor coverage. It is one base station. You have one spare part. It is just a question of configuration and licensing of that hardware element.
Good.
Yeah.
Should we move on to the next one, Simon?
Yeah, right. Let's go to the next use case. So, by the way, if you have any questions or remarks, please put them in the chat.
That's a good point. Yeah, because we'll try and get to some questions, but it's we're probably going to need to speak to you directly. There's a lot of detail in this, and we're happy to share it if we understand the specific applications.
Yeah, and by the way, if you find this interesting, this discussion here, so we will have about the same topic tomorrow evening.
That's right.
We will have a presentation, and since it is live, we might be
we may be talking about other stuff,
right? So it's not identical. So
that's
it's
right.
not.
There's no script here.
Okay, so. But let's have a closer look at this use case here. So if you try to cover, for example, a railway line, if this would be from left to right.
Well, and you mentioned railway line, pipeline, any linear application really is what you're.
So that's the typical use case.
Right.
Yeah. So, and typically use case would be here for kind of low density networks. So if you have so these bubbles here, the different colors symbolize the coverage area of a base station, and now this dotted line symbolizes the area where you're not allowed to reuse the same frequency.
Yeah.
So that means in order to build this straight line, it depends a little bit on the environment and on the overlap you're applying. But in this example, we would use 5 frequencies, and now at this point you can reuse the same frequency again. And then you go frequency 2, 3, 4, 5, and so on. So you can cover the whole line.
Okay.
Right. And now when you do the same thing with our frequency sharing, you're actually sharing the same frequency with 4 adjacent base stations.
So grouping the base stations with the same frequency and creating an RF.
Exactly. So we have again this kind of have again this kind of master-slave configuration.
Right.
And from mobile terminal point of view, it is like one big base station. Yeah. And also here you have actually the area, the dotted line that symbolizes the area where you're not allowed to reuse the frequency.
I see.
So, and now when we see now, if we make a similar cluster here for the next frequency, you see actually that you can reuse the frequency 1 after the next cluster again.
And now could that be, Simon, that could be sets of frequencies, right? It's not just a single frequency, it can be.
Yeah. So actually our BS422 is a software-defined radio, and you can actually have up to 4 frequency per physical
so
carrier.
In the box, we can actually have 4 carriers.
4 tetra carriers, yeah.
Okay.
So that's the maximum you can put there.
And it's and we can handle both voice and data.
Yes, so you have all tetra features and also the DMR
as well.
features.
Okay, good.
That's correct. Right. So you can go there, and the good thing is also here. So this is, of course, as I said it before, it's for low density networks, because you have in this area of this F1, it is logically just one base station, which then kind of limits the capacity. But if maybe at a later point of time you think, no, we need to add capacity to the whole system, not only carrier wise, but we would like to add base station, you can always transform a slave unit to own master unit, so you can always at a later point of time you can actually even go up to the upper picture there.
Okay.
So because it's
you can actually build to something a little bit more dense in terms of your capacity requirements.
So you actually do have the full flexibility in using it either as master or a slave unit.
Okay, good.
So, good. Then going to our third use case. So here you have an example of a like airport terminal. Airport terminal. But this could apply, for example, also for some industry or refinery or something like this.
A plant or anything like that. Yep.
You actually, from coverage point of view, you would say one base station is sufficient to cover the whole area, but the customer would like to have 2 base stations in order to have full so-called geo redundancy. So in case one base station fails here, then the other base station actually could take over
the coverage.
Yeah. And traditionally, there were basically 2 ways how you can achieve this. So you can either have two active base stations and they just run in parallel. So they just,
on different frequencies. So.
Yes, exactly. And that's exactly the point. So then you need two frequencies. So you need the double amount of frequency, actually more than you actually need, because the idea is that even in the redundant case, you need to have the full capacity available.
Right.
So, or the other way is to have an active passive base station. So this one would be active, and when it fails, then the left one will take over with a certain delay. You need to start up, and mobiles need to re-register. So there is some kind of operational impact, and also
could be a period of time where service is down, right?
There is potential, or there will be as a kind of a
switchover, right?
Yeah, and then also one thing is also, of course, from operating point of view, if you have a passive base station, you need to ensure that the base station is actually operational in a way.
Maintain it and keep it online,
so
right?
There are different ways how to do it. So you can switch over once a month or something like this, but still it needs some operational actions. So how you can do it with frequency sharing is actually that you put both base stations, one as master and one as slave, and they cover the same area. So if they are close to each other, so they have kind of full overlap.
Same coverage area, same frequency, just and in synchronization, so that they don't create the interference or anything like
so
that.
They are fully synchronized with each other,
and they're always available. So but you've got
if any of those fails, then the system will work again. So even if the one that is configured as master fails, so the other one will
and I suspect by having two transmission points, you can also fill in small areas of coverage. So where your coverage is weak on one side, you might be able to fill in some.
So statistically, it will improve your coverage. Because it's at the end it's a statistical question how good coverage you get.
That's a good use case.
And so in a way, the coverage is as good as you would have two active base stations, but you would need only half the number of frequencies. So that's the point. Right. Good. So that was about our 3 use cases. And now, dear audience, we would like to ask you about your actions. So
if you've got, if you there's a poll going to be put up on the SwapCard platform. If you can let us know, what you think the main benefit. What do you think this feature would mean to you? If you could just click off one of those answers and send it in, we have our pollsters. This is in obviously everybody's voting in the United States today, so we felt we had to do something like this.
So we have to be in here.
So we'll if we could do that, and then we'll share the results as they come in.
Yeah, because it would be really interesting for you. So what are the main? So I think you can vote only of one of those. So either it's the frequency saving, you can simplify your network architecture, it's the redundancy you gain, or then also the RF performance when you compare it to
or repeaters. Of course none of the above. Maybe it's none of these things mean anything to you.
Yeah,
so.
Exactly. If you think no, it's not actually for use for me. Yeah,
good.
Yeah, please give your vote, and we will have a look at it later and during also the question and answers.
Maybe we should just wrap up then and summarize some of the things that we.
Exactly. Yeah. So to summarize here, so you have, if you build a network with the BS422 compared to using an external repeater system, so you have only one hardware.
Single piece of hardware.
So it's unified management, unified spare parts. So you will save lots of operational costs and also lots of hassle during the operation and maintenance.
Well, it reduces your total cost of ownership as as you predict. If you listen, during CCWeek, there's many different presentations. I mean, I've heard in sitting in, some people expect their systems to last for 15, 20 years. In fact, we're involved in some projects that have expectation of 30 years, so
the time span is very long.
So you start to calculate that out, and it could be significant. So,
right. Then the redundancy we discussed. Frequency efficiency is, of course, one of the key drivers we originally had when I mentioned the drivers. And then also actually one point I did not mention before. So if you use if you use normal repeaters, you will not have RX diversity.
Right.
And actually the whole RX sensitivity will be much less, especially with off-air repeaters, because the gain of the off-air repeaters is usually quite weak because of the limitations on the antenna isolations. But definitely you're far better off with a hardware very similar to the hardware,
right.
Similar to the base station. So the message here is really, so with the BS422 you can build a extremely simple network, easy to maintain. It will be cost efficient in long term, and from a reliability point of view, you can build redundancies that are much superior compared to conventional repeater systems.
Great.
Good.
So yeah, sorry, Simon.
Yeah.
If you I just want to reiterate, if you want to get these slides or have a chat or dig a little bit deeper into anything you've heard during the course of this, then please send us your name, your email address, how we get in touch with you. We'll send out the slides and then we can respond to some of the questions. And I think we're going to take some questions here from the audience.
Right. Yeah, we have seen also a few questions already came
okay,
in
that's
here.
What those are. Okay,
so,
good.
So we will actually now move to our question and answer sessions here, just shortly about us. Yeah, some more details if you're interested. Of course, you will see our information also on the CCW.
So what have we got? What have we got for questions, Simon?
So we have here already a few that came in from Fernando. So he's asking about the TX power of the BS422. So he's asking whether it's the same as
the BS421.
BS421, right? Which is the traditional, so the older version of our outdoor base station. So I mentioned before, the BS422 is software-defined radio, so you can support multiple carriers. So the output power depends a little bit on how many carriers you are actually transmitting.
But if we only had one, because the BS421 is a single carrier, so if you're comparing it to the BS421, what are the
BS421 has 10 watt and the BS422 with one has 25 watt.
25 watts, and if it's in DRMR mode, it has 50 watts.
It has 50 watt, yeah,
so,
right.
Okay.
Yeah, so yeah, sorry, we talked about Tetra now here. So but the BS422 with two carriers has actually the same Tetra output power as the BS421 with one carrier.
Correct. Yeah.
All right. Oh, we have lot of questions. Yeah. Right. And I think you see us again. Oh, by the way, now when you see the camera again, the slideshow ended. Maybe you can show us the hardware we have been talking about.
Right. That's true.
Right.
Yeah. This is the BS422, and this is. Just to give you an idea of the size of it, it weighs about what, 18 kilos?
I think even less. Yeah.
Less than that.
And it's a similar size as a repeater, and you can really install it almost everywhere. IP65 protected.
Outside, on a tower, indoor on a comm shell. There's some more questions coming in.
Yeah, I just checked whether the poll is already there. Yeah. I opened the chat. Just published the poll. Can we see it?
There's the
poll. Here we have.
Poll.
All right, that's now very interesting. So,
frequency savings.
So we can publish now the results. Half of you voted that frequency savings is really the key driver. So that means one interpretation could be, of course, also that most of our customers have low density networks. So it's not like commercial networks, which are often capacity driven. So coverage is really the driver. So frequency saving is really, and it's also OpEx costing.
And simplified network complexity was another big one there too.
Yeah, so it was 25, and then we have a similar redundancy and RF performance.
There you go.
And actually, we did not get a single vote that it would be useful.
Useless.
Yeah, right.
That's good to know. We got jobs.
Good to hear. Yeah. All right. So let's the one thing.
I think we answered that one in the course of
it, right? It was the question whether
multiple RF channels, so we can support multiple RF channels on that. How many BS422 slaves can be connected to a master base station? That's a good question.
Yeah, right. So I explained it before. So we have a master, and then you have several slaves. So technically, there is no hard limit in a way, because you can actually do the functionality also from a server. No, it doesn't need to be a base station. So from processing point of view, if you use the base station as master, then the limit is about 10. But in practice, the limit will actually come earlier. So because if you make a very big cell at a certain point of time, you are again capacity limited.
Right, and then it becomes it's sort of used. So it really is. I guess the answer to that is, it's going to be an engineering driven answer to your question as you build the.
Exactly, it depends how much capacity you need, and I would say typical value. So it's a balance between frequency use and capacity.
Right,
five or six slaves is maybe.
What do we got there? Can you
mix frequency sharing and normal base stations within a network?
Oh, yeah, that's a good question too. So in an area where you'd have a sort of a traditional network where the different sites have all the same frequencies, and then you've got maybe a small part where you want to create a bigger bubble, if you will.
Exactly. So you can freely mix it. So the frequency sharing or normal base stations, and you actually within the DAMM network infrastructure, you can also mix it with the other base stations we have. So before we mentioned the BS421 or BS418, it can be mixed everything into one unified network.
Good.
And of course, then everything is also managed with the same network management system.
How does the BS422 work on a Tetra system? How is the integration with the Tetra exchange? I don't know what the Tetra exchange is.
There is DXT is mentioned. So this refers to Airbus technology. So the BS422 is based on distributed network architecture. So you have all the network-wide data is in the base stations. Also, we do not have a central switch, which makes it then very easily scalable, and there is no kind of direct interoperability to the DXT itself or network from other manufacturers. But if you're interested actually in interoperability between networks,
that's a good point. Yeah. We've got later this afternoon. We're going to have Hauke Holm, our deputy CTO. He's going to be with us, and we're going to be talking about interoperability. And that's probably a question there. But if you've asked that question, please send us your email. We'd like to understand a little bit more about what it is you're looking for. We can hopefully address it in a little bit more detail.
Yeah. Right, and I think now we are coming soon to the last. We have 2 minutes to go.
Yeah.
What happens if a base station loses IT connection? So all our base stations are connected via the IP backbone, and this is actually independent from this
feature set.
From this feature. So a base station can also work in this kind of local trunking mode, but it can also be shut down depending on the configuration. And maybe just one thing also, I just mentioned before the distributed architecture. Actually, if a DAMM base station loses connectivity to the network or to another base station, since you have all the network-wide data, everything is available in the base station. Right. You still have all the interfaces are available depending on the configuration
of the way you've laid out the network.
Dispatcher connectivity or some zip gateway or whatever. So everything is in there actually.
Good. Maybe one more, I think, Simon.
Yeah,
I think then we're getting down to the wire here.
Exactly. All right. So we are not allowed to run over time. That's the solution.
Does it support data services, and what is the maximum data rate that can be supported? Well, that's a great question.
Yeah. So this is. So when you have base stations in frequency sharing, it is like one big base station. So there is no difference in the services. So exactly the same service.
Same service. So voice and data, and so they would be in a Tetra carrier. You would have 4 slots that would produce 7 and a 7.4.
7.2 bit. So raw data.
Right. Raw data. So again. And then in DMR, you would split it into 2 in a 12.5 kilohertz channel. But great question, and we'd love to chat with you more about that. Please get in touch with us if you've got some time. Put your name and your email address, and we'd love to chat with you more about that.
Please remember also the other sessions from DAMM. I think for us, it's time to say goodbye.
Time to go.
Thank you for your attention.
Yes, thank you. Thank you very much,
Okay.
everybody.
Thank
Take
you.
care.
Bye-bye.
Thanks, Simon.
Thanks, Dave.